back to another episode of Principles of Micro. Today we are finishing up Chapter 11. We are looking at what's called third degree price discrimination. So we learned earlier about the first two degrees. We saw there was perfect or first degree price discrimination. That's where you charge each consumer their maximum willingness to pay. Second degree was also called bundling. You offer a discount for buying in bulk. All other kinds of price discrimination are considered third degree. This usually involves basing on things like your demographics, like a senior discount is an example of third degree price discrimination. So I'm going to skip over the welfare analysis because it's going to be exactly the same as it was back in the earlier episode. We're looking at second degree price discrimination and bundling. Some of our big takeaways were that producer surplus will definitely rise. Social welfare also rises. Consumer surplus may either rise or fall. It depends. So the consumers who have the highest willingness to pay are going to be harmed because they'll be charged more now. However, the consumers with the lower willingness to pay will benefit. It's not quite clear which effect is stronger on consumer surplus. So there's one surprising result with third degree price discrimination, and that's called the damaged goods theorem. So paradoxically, damaging on purpose some of your own goods, if you're the firm, can be efficient, can raise your profits, and even raise social welfare. So here's the article that introduced this idea. Well, maybe introduced is not quite the right word. They popularized it. It might have been around earlier. So we talked about this certain processor chip that Intel is making, and they started making the chip that's working fine, and then intentionally they actually reduced the quality of the chip. They actually disabled the math coprocessor, and this italics are not mine. They put the italics in the original paper. So it costs more to make this chip that's actually worse. Why do they do that? It's in order to price discriminate. So people with the low willingness to pay who just want something that's cheap, they're going to buy the disabled chip at a low price that was selling for a price of $333. The folks who have a higher willingness to pay, who I ask them to have quality is the most important thing to me, they pay $588 for a chip that is fully functional. So by intentionally damaging their own goods, they now have the possibility of price discriminating. They can now sort out the people with high willingness to pay who care about quality from the folks who have a low willingness to pay, and that can raise producer surplus and also raise social welfare. Effect on consumer surplus is, like before, unclear. So because now we're charging two different prices, the people who are paying the high price for the high quality good, they're now worse off because the price is higher than it would have been if there had been just one price. The folks who get to buy the cheaper good are better off because the cheaper one is less expensive than it would have been if there had been just one chip sold at one price. So normally you think if you destroy something or damage something, that's a bad thing. Surprisingly though, it can actually be beneficial for society, for producers, and possibly even also for our consumers. Alright, now I'll go through some numerical examples of price discrimination. So let's go back to Kirksville, Missouri, where I spent 4 years teaching at Truman State University. So it's a very small town. I've told you about this in earlier episodes. The population out there is just 17,000. They gotta drive more than an hour to find a bigger city. So very, very rural area. So they've only got one movie theater. That's not a big surprise. Let's say you're in charge of running this movie theater, and we're looking at what's the right senior discount to charge. So you estimate demand for each category. So seniors have this demand curve, and other folks have this demand curve. As I mentioned earlier, seniors often have a lower willingness to pay. That's because they are retired, and well, most of them are retired, and that means less income, which usually means lower willingness to pay. So go ahead and pause the video here and calculate what price you should charge to each group. So press play when you have finished figuring that out. Alright, I'll assume you have worked through the problem by now. The first thing we got to do is fill in our table. So we find total revenue by just doing price times quantity. 20 times 0 is 0. 15 times 10 is 150. 12 times 20 is 240. And so on for these other numbers over here. Do the same thing for the seniors. 20 times 0 is still 0. 12 times 10 is 120. And 10 times 20 is 200, etc. So now we have total revenue. Next step is to compute marginal revenue. We have to do that because we know from earlier that the profit maximizing rule is marginal revenue equals marginal cost. So you gotta find marginal revenue first before you can apply that marginal revenue equals marginal cost rule. So let's go ahead and do that. We know marginal revenue is the change in total revenue. So total revenue is 0 here, and it's 150 down there. That's an increase of 150. Similarly, here going from 150 to 240, that's an increase of 90. 150 plus 90 is 240. 240 plus 60 is 300. And 300 minus 20 is 280. So at some point you can see that's not a mistake. At some point you can see if you cut price far enough, then your total revenue starts going down. That means that marginal revenue can be negative if you produce too much and charge too little. So it works the same way out for the seniors. So here total revenue goes from 0 to 120. So 0 plus 120 is 120. 120 plus 80 is 200. 200 plus 40, 240, and so on. 240 plus 60 is 300. Once you fill in marginal revenue, you apply that profit maximizing rule, MR equals MC. For others, the people who are not seniors, then that occurs when price is 10 and quantity is 30. For seniors, marginal revenue equals marginal cost when price is 750 and quantity is 40. So what that implies is that you charge everyone else a $10 ticket price and you charge seniors $7.50. Equivalently, you could just charge everybody $10 and offer seniors a discount of $2.50. It works out the exact same way. So that's how you work through an example like this one where we have a table. Here's a more algebraic problem. So let's go back to universities and tuition financial aid. So let's say I separate students into just two groups. There are students who have rich parents and there are students who don't have rich parents. Of course, in the real world, they get much more complicated than that. We're going to try to keep things simple here so that the problem is tractable. So, unsurprisingly, the folks with rich parents have a higher demand curve than the people who are not rich. Also, the people who have rich parents are less sensitive to price. So QR is the quantity of students with rich parents. QN N for not is quantity of students with non-rich parents or not rich parents. So if price goes up by 1, their demand falls by a lot more. Their demand is, you might say, more elastic. So the marginal cost is going to be 100 times the total quantity of students. So your mission is to find what tuition should the university charge to each group. So we'll treat the university as being a profit maximizing firm. So use the same profit maximizing rule that we typically use. And just to give you a hint, we know that from before I asserted that marginal revenue always has the same the same intercept as demand, but has double the slope. So go ahead and pause the video here and work through that problem. When you're done, press play. Presumably you have solved the problem by now, so let's go over the answer. So the profit maximizing rule is marginal revenue equals marginal cost. We have to find marginal revenue first. That's going to involve using our hint over here. So for the rich, this is their demand curve. Intercept is 30,000. Their slope for demand is minus 100. Marginal revenue has double the slope, so now it's going to be minus 200. For the students whose parents are not rich, the intercept is 16,400, so we keep that for their marginal revenue curve. Then we double the slope. The slope of their demand curve is minus 500. That becomes minus 1,000. Alright, we got marginal revenue for both the rich and the non-rich. Now let's use our profit maximizing rule. So this will involve a bit of algebra. So here's the rich student's marginal revenue curve, 30,000 minus 200 QR. We said marginal costs were 100 times QR plus QN, so we set those equal. For the students whose parents are not rich, we have their marginal revenue curve as before, and we also set that equal to the marginal cost of 100 plus total quantity of students. So we have two equations here, and we have two unknowns we're solving for. We're solving for QR and for QN. So let's go through that algebra. So I'll first work with the condition for the rich. Doesn't matter which one you do first, it's always going to work out the same either way. So what we'll do is I'll first expand this. So that's 100 QR plus 100 QN. And next I'll move that 200 QR to the other side here. And I'll bring the QN over there. So that means we have 100 QN, but then we're putting it on the other side, so we minus 100 QN over here. We have 100 QR plus 200 QR. That's a total of 300 QR. So to isolate, or I might say in these times to quarantine the QR, you divide both sides by 300. That's going to come out to QR being equal to 100 minus a third QN. With that in hand, we now go to the equation for the not rich. So we have their marginal revenue set equal to their marginal cost. However, now we know what QR equals. So we're just going to plug that in for QR. So we have marginal revenue equals 100 plus QR, but QR is just that. QR plus QN. So let's do some more algebra. We have minus a third QN plus QN. That's going to be 2/3 QN. so that's over there. And I also pushed that 1000 QN to the other side. So it's going to vanish from this side, that's going to reappear over there. Next step, I'm going to expand what's in the parentheses here. 100 times 100 is going to be 10,000. 100 times 2/3 QN is going to be 200 over 3 QN. And we still have the same 1000 QN over here. We're out of space on this slide. We're going to go to the next slide to work out what comes next. So, what did I do? I subtracted the 10,000 from both sides. So now I have, wait, is that a mistake? Okay, so typo on this slide, this 10,000 should not be there. I'll fix that in the slides that I'm posting up on my courses. So ignore that 10,000. The rest of it's right. So to get a common denominator, we then multiply top and bottom by 3. So I have 3,000 over 3 QN over here. Again, we're ignoring that 10,000. That's a mistake. So that does not appear down here. So I have 6,400 equals 200 over 3 QN plus 3,000 over 3 QN. Now that I have a common denominator, I can combine these guys, and I get 3200 over 3 QN. Now to quarantine our QN, we multiply both sides by 3 over 3200, and you can see I've rigged the math a little bit to make things work out cleanly. That comes out to QN equals 6. Alright, so we can plug that into the condition we had earlier. We showed that QR is going to be 100 minus 1/3 QN. If you plug in QN equals 6, we know that 1/3 times 6 is 2. 100 minus 2 is 98. So QR is 98. We're not quite done that yet, though. We've established which quantities we're going to have. We still have to work out what price do we charge each group. So what's tuition going to be for the rich versus what's tuition going to be for the not rich? You get that by plugging into demand. So for the students with rich parents, demand was this, P equals 30,000 minus 100 QR. We established that QR was 98. 98 times 100 is going to be 9,800. 30,000 minus 9,800 comes out to 20,200. So that's the price you charge the folks with rich parents. For the students who are not rich, they had a lower demand curve and one that was also more price sensitive. So intuitively, you'd expect we're going to charge them a lower price. We do. We established that QN is going to be 6, so you plug 6 in over here. 500 times 6 is going to be 3,000. 16,400 minus 3,000 is going to be 13,400. So that's the tuition you charge them. So price discrimination means we're going to charge a lower price to the students whose parents are not rich and a higher tuition for the students with rich parents. Like I said before, you probably got agitated when you hear about discrimination in this chapter, but it often actually means equalizing things by charging more to the rich and less to middle class and poor. Though again, not always. It often means that, not every time. So that wraps up chapter 13, and that concludes our episode. Be sure to join us next time when we learn about a new chapter in micro. Stay safe out there.